There's this article that I published back in 2003 presenting the simulation argument. First, that almost all civilizations at our stage of technological development go extinct before they reach technological maturity. A second possibility is that there is a very strong convergence among all technologically mature civilizations. And the third possibility is that we are almost certainly living in a simulation.
If you are familiar with the movie Matrix, then you must have heard Morpheus say at the very beginning, before taking the red pill,
"What is real?"
It's just electrical signals that are being fed to our brain through our perception, and we decode them and construct the reality around us. Is this life we live in reality? Well, considering our lives today and all our current experiences, maybe a better question is, what aspect of your life actually defines reality? Could everything we see, feel, and know about, or rather think we know about, our universe be artificially made? Let's find out. Some expert scientists argue that the idea of living in a simulated world is not just a question of if, but a highly likely possibility. You'll be shocked to learn that these experts aren't just all talk. There's already growing evidence to support this theory. To understand this theory, let's look at where this concept comes from. The notion of the universe being a simulated construct is not new. Similar theories have existed as far back as ancient civilizations worldwide. This theory was contributed by various scientists around the globe. Theories like Vopson's theory, a theory belonging to a branch of science called information physics, state that the universe behaves just like a computer, ordering and deleting unnecessary information. The owner of the theory, Dr. Melvin Vopson, says that images, sounds, perceptions of touching things, and all our senses are just electrical signals that are being decoded by our brains. Dr. Vopson also says that the human brain is nothing more than a biological computer. There are many different theories like Vopson's theory, but the modern simulation theory is mainly attributed to philosopher Nick Bostrom from Oxford, who wrote about it in 2003. Bostrom presented the simulation trilemma, suggesting that one of these three scenarios must be true. The first one was that our existence might follow one of three paths. We perish before crafting a simulation, we gain the capability yet choose not to, or we are undoubtedly within a simulation. Bostrom believes these scenarios hold equal likelihood in one's life. I don't think the notion is controversial because we use computer simulations to study populations and weather predictions, and in the entertainment industry, it's like we simulate everything. Let's say a civilization achieves realistic simulation. The most obvious choice would be to simulate its own origins, right? Bostrom calls this simulation an ancestral simulation. You have to agree that a civilization that could create such a simulation would not create just one. It would definitely create numerous simulations, and those simulated civilizations might craft their own universal simulations, and on, creating a recursive pattern. A scientist said, "Now you're a character in that world, and you think you have free will, and you say, 'I want to invent a computer,' so you do. Hey, I want to create a world in my computer, and then that world creates a world in its computer, and then you have simulations all the way down." In an interview, Elon Musk was also asked if our universe is the primal reality, and he said, "The odds that we're in base reality is 1 in billions." Unlike Elon, Neil deGrasse Tyson, an American astrophysicist, author, and science communicator from Harvard University, claims we have a 50-50 chance of living in real or simulated reality. I don't know about you folks, but the 50% possibility of our world being artificial is pretty high, don't you think? Our world could be entirely artificial. While scientists discuss this theory, philosophy and metaphysics also explore it. In fact, simulation theory is not scientific theory. Simulation theory isn't math. It is philosophy. It isn't physics. It's metaphysics. We need concrete proof to know if we live in a simulation. Okay, first we need to ask ourselves a few questions. If, before the Big Bang, there was no space and no time, what was there? What about from a religious point of view? God created everything, right? Where was he before? What made God snap his fingers or do whatever he did to make everything happen? What caused the Big Bang to occur in the first place? If you ask a physicist to explain what existed before the universe, they'll give you an answer about quantum foam. I don't know, or maybe dark energy or something just as bonkers as the Big Bang. Yet strange ideas like simulation theory make us wonder. Because the theory says that the universe was just dormant, someone somewhere else decided to boot up a program. And in that program, all the laws of the universe, from electromagnetism to gravitational force, are written into the program. Phenomena such as the speed of light get a value in the source code. There's also a code for Planck's constants of mass, speed, and time. The theory also accounts for Avogadro's number in its code. In addition to all these, there are many other rules that govern the behavior of everything in our universe. Do we blindly accept the world around us? Or should we question everything, unable to trust our senses? If simulated, who made this reality and why? Many deep, complex questions arise. Let's get back to trying to prove our theory. For now, no hard evidence proves or disproves the simulation theory. We can't say for sure either way. All we know is what we experience daily, which may be an illusion. Understanding reality's true nature remains a puzzling, unresolved mystery. Did a powerful supercomputer construct our entire existence? Only time and further investigation will tell. Within a computer-simulated environment, a notable indication is the modification of a variable. Have you encountered the phenomenon of déjà vu, the uncanny feeling of re-experiencing a particular moment? Some, including the well-known science fiction writer Philip K. Dick, suggest that this occurrence might indicate the system adjusting itself. Remember, Dr. Philip is one of the most influential science fiction writers ever. He has had movies made based on his books. Movies like Blade Runner and Total Recall are just a few movies that conceptualize this theory. He believed there are many universes, and sometimes those other realities flow into ours. According to him, he had visions of this and decided to write stories about it. One of the stories he wrote is The Man in the High Castle, which discusses these visions in depth. In his theory, Philip says that millions of people remember distinctive things that didn't happen because of a glitch in the simulation. You know, things like the evil queen from Snow White who looked into her mirror. Most people recall her saying, "Mirror, mirror on the wall," while in reality she actually said, "Magic mirror on the wall, who is the fairest one of all?" This effect is mainly referred to as the Mandela effect. This is a situation in which a large mass of people believe that an event occurred when it did not. So, Philip claims that the Mandela effect is a glitch in reality. Nevertheless, skeptics commonly reject such ideas, pointing out human mental limitations. They say that the human mind is usually unreliable. They even refuse to accept this as evidence of the simulation theory. But that is not all we've got. But first, why don't you drop a like on the video and support us by giving us a subscription? Many people today think simulation theory is crazy. Among them was theoretical physicist Dr. James Gates, who also felt the same about simulation theory until he started studying quarks and electrons. During the study, he found error-correcting code buried deep inside the equations used to describe string theory. String theory is an idea in theoretical physics that states that reality comprises tiny vibrating strings smaller than atoms, electrons, or quarks. Some claim that this is a coincidence. Humans look for patterns in chaos because that's what we're programmed to do. What is interesting is that by trying to debunk the simulation theory, they actually end up proving it. No matter what we study, whether it's something the size of a galaxy or as small as an electron, everything in the universe seems to follow patterns and rules. In other words, a program. When we look at simulated games like Grand Theft Auto, we can see how advanced simulation can look with sophisticated technologies. Elon Musk says that when he was a kid, the world's most advanced video game was Pong, which was nothing more than two rectangles on a screen. It has improved drastically from this to how video games look now. Imagine what games will look like in the next 5 years, the next 50, or even the next 1,000. But far from games and more complex, simulating an entire universe, how big of a computer would we need? According to research, it is estimated that there are 10 to the power of 80 atoms in the universe. That's a lot. especially if each particle needs 128 bits to calculate its position and momentum. This will give you 10 to the power of 83 bits, and that's just for data storage alone. The figures are crazy. Apart from this, we also need computing power to track what each of those particles is doing. If we say we use 2 floating point operations per second or 2 flaps per particle, we will get 2 times 10 to the 80th power of flops. That is a whole screen full of numbers, and this is the computing power for just the stuff in the universe. We haven't gotten to human intelligence yet. Scientists say that the human brain can perform 100 trillion calculations per second. This is the equivalent of 100 teraflops. What if this number were to be multiplied by the billions of people worldwide? The numbers would be too ridiculous to say. The simulation would need access to multiple structures called Dyson spheres to power all of this. A Dyson sphere is a hypothetical megastructure that captures a large percentage of its solar power output. These megastructures will have to capture 100% of the energy of a star, or the simulation will have to harness the energy from black holes. Sounds far-fetched, right? However, recent developments in neuroscience and cognitive psychology offer fascinating perspectives on memory and perception. This continuous exploration enhances our comprehension of déjà vu and encourages profound contemplation on the essence of reality. While skeptics may remain doubtful, investigating these occurrences underscores the significance of interdisciplinary studies in unraveling existential enigmas. Dr. Gates had a change of mind about simulation theory. In 2017, researchers at the University of Washington put computer code into DNA strands. This shows that nature follows math rules. For example, the Fibonacci sequence adds the last 2 numbers to get the next. This leads to the golden ratio, a pattern found in nature. Flowers, petals, tree branches, and even human body parts show this ratio. From seashells to galaxies, Fibonacci numbers are there. This suggests an order in the universe. Critics may say these patterns are just coincidences. We humans see patterns where none exist. Ironically, doubting simulation theory supports it. The universe has recognizable patterns and rules, like a programmed system. Computing power advances rapidly, as Moore's law shows. This hints that we could someday simulate a whole universe. Simulating it may not require accounting for every atom and particle. We could selectively render it, like in modern video games. This challenges the idea that only the universe itself can simulate another. Though famous physicists like Dr. Mikio Kaku object, simulation theory fascinates scientists and philosophers. They keep looking for proof for and against this idea. You know the guy Elon Musk, right? That super intelligent tech leader? Well, he talks about this weird idea a lot. He thinks there's almost no chance we're living in the real world. And some brilliant people actually take this seriously. With all the tech progress over the past 50 years, we can make virtual worlds that seem totally real. And nothing is stopping us from making them even more realistic. In fact, many folks think that one day, virtual reality will be so good that you can't tell it apart from actual reality. It's kind of creepy when you think about it. It makes you wonder, what if we're already living in a simulation? What if some crazy advanced civilization created this whole thing like a video game to study their history? These super societies might have all kinds of reasons to run simulations, and they could run a whole ton of them. So, most beings might be stuck in fake worlds, not genuine ones. Wild concept, huh? Bostrom's idea goes beyond making hyper-real worlds. It says conscious beings could start inside a simulation. Unlike The Matrix, where humans are hooked to real bodies, Bostrom thinks conscious minds happen within the simulation itself. However, there are reasons why simulating a conscious mind might not work. First, we don't fully understand consciousness yet. How it exists and why we have it is a huge mystery. The question of how living things create inner, subjective experiences has confused thinkers for ages. Even advanced neuroscience can't explain it. This is the famously tricky, hard problem of consciousness David Chalmers talked about. We're still unsure what solving it would mean. Second, more scientists and thinkers have argued that consciousness blocks our current materialist science. They say we must go beyond our usual materialist ideas to understand it. Chalmers and others propose that consciousness could be a fundamental part of reality that science must accept. However, digital simulations may not be suited for making consciousness happen. Digital computing languages could just be codes without the unique meanings of consciousness. While simulations might mimic mind behavior, we don't know if the inner feeling of consciousness can exist there. Bostrom's idea is that we may live inside a computer simulation, but Koch argues that consciousness can't be computed. So conscious beings like us couldn't live in a simulation. Our minds work with electric signals, basically ones and zeros. This hints that we could make a digital copy like a digital brain by copying those signals. Yet scientists say the brain is too complex for simple math. This complexity makes us wonder about reality and being aware. It brings up ideas like the Cartesian demon, and maybe we already live in a simulation. Also, thinking about life outside of our bodies challenges what we know. These thoughts push us to ponder awareness and existence's true nature. The simulation idea especially makes us reflect on the core parts of reality and our place in it. Yet our brains are conscious and simulate reality. Advanced civilizations might understand consciousness deeply. If consciousness is real, they may create technologies to control and use it in new ways. In the real world, our ability to zoom in and observe finer details extends from bacteria and viruses to atoms, quarks, and superstrings. These fundamental components form the intricate fabric of reality. Furthermore, the analogy of zooming in on a photograph highlights the concepts of scale and resolution. Just as a high-quality photo can be enlarged to reveal smaller and smaller details until it reduces to a single pixel, our perception of reality can also be viewed in varying levels of detail. However, like a computer screen with limits in displaying detail, our perception of reality also encounters limitations. These constraints may arise from the inherent structure of the universe or the capabilities of our sensory organs and cognition. Thus, while we strive to understand the depths of reality, we are confronted with the realization that our comprehension may be bounded by the constraints of our perception and the fundamental nature of existence. When observing shadows on a wall, they appear real, but upon diverting our gaze, they vanish from existence. This phenomenon underscores the elusive nature of perception and its role in shaping reality. Consider the scenario of a falling tree. If it topples in a forest with no one present to hear it, does it truly make a sound? While we confidently assert its occurrence when witnessed, the absence of an observer challenges its existence in an unperceived realm. Moreover, these contemplations extend beyond mere philosophical musings. They delve into the profound implications of human consciousness and its influence on our understanding of the world. In the realm of modern physics, quantum mechanics presents similar conundrums. The act of observation alters the behavior of subatomic particles, blurring the line between observer and observed. These reflections prompt us to ponder the nature of reality itself. Are we merely participants in a grand simulation where perceptions construct the fabric of existence? In the face of such uncertainty, the distinction between what is real and what is perceived becomes increasingly blurred. We are left to navigate a world where the echoes of existence may resonate differently depending on the presence of an observer. Imagine a vast computer that spans the size of the solar system. This is the Matryoshka brain concept. It's like something out of science fiction, but it sparks some fascinating questions about the nature of reality and the limits of technology. Picture this: a mega-computer generating the entire universe, mirroring every detail from the tiniest atom to the grandest galaxy. It sounds incredible, doesn't it? But, like many grand ideas, it comes with its fair share of challenges. First off, let's talk about resources. Creating a mega-computer of this scale would demand more power and materials than humanity currently has at its disposal. It's like trying to build a skyscraper with only a handful of bricks. It's just not feasible with our current technology. Then there's the question of whether such a colossal machine could even exist in theory. Some scientists argue that the sheer complexity of such a system might defy the laws of physics as we understand them. It's like trying to fit an elephant into a shoebox. No matter how you slice it, it just doesn't seem to add up. Let's shift gears for a moment and think about how we experience reality. When we look around, we see a rich tapestry of sights, sounds, and sensations. But what if I told you that not everything is as it seems? Consider the analogy of a video game. When you're playing, the game doesn't render every single detail simultaneously. Instead, it generates the world around you as you explore, focusing its resources on what's directly in your line of sight. It's a clever way to save processing power and create a more immersive experience. Similarly, some theorists propose that our reality operates on a similar principle. They suggest that the universe only renders the things we actively observe, conserving energy by omitting unnecessary details. It's like living in a constantly updated simulation where the world shifts and changes based on where we direct our attention. This idea ties into the concept of quantum superposition, the notion that particles exist in multiple states until observed. In other words, reality only solidifies when someone is there to witness it. It's a bit like Schrödinger's cat, but on a cosmic scale. You might be thinking, if reality only exists when I'm looking, does that mean I'm living in some kind of cosmic Truman Show? Well, not exactly. While it's an intriguing concept, it's also highly speculative and, as of yet, unproven. But that doesn't mean it's not worth exploring. In fact, understanding the nature of reality is one of the fundamental questions of human existence. It's like peeling back the layers of an onion. Each revelation brings us closer to understanding the true nature of the universe. And speaking of exploration, let's talk about No Man's Sky. This 2016 game captured the imaginations of millions with its vast, procedurally generated universe. Each planet, star, and galaxy was created on the fly, appearing only when players decided to explore them. Now here's the kicker. Just like in our hypothetical megacomputer, No Man's Sky only renders the details that players interact with. It's a brilliant example of how technology can simulate a complex, ever-changing world without overwhelming processing power. Ultimately, whether we're talking about matryoshka brains or quantum superposition, the underlying question remains the same. What is reality, and how do we perceive it? It's a question that has puzzled philosophers, scientists, and armchair theorists for centuries, and is unlikely to be answered anytime soon. Perhaps that's the beauty of it. As we continue to push the boundaries of our understanding, we open up new avenues of exploration and discovery. Who knows what secrets the universe holds? Maybe the answers are closer than we think, waiting to be uncovered in the hidden depths of reality itself. Let's take a step back and revisit Bostrom's ideas. He proposed the concept of computers so powerful that they could create virtual machines, a concept well known in computer science. These virtual machines, like Russian nesting dolls, can be nested within each other, allowing for the simulation of increasingly complex systems. Imagine a world where technology has advanced to the point where computing power is nearly limitless. In this hypothetical scenario, the inhabitants decide they want to play video games, so they set out to create a virtual universe within their computers, a world with its own laws of physics, inhabitants, and history. Here's where it gets interesting. As this virtual world evolves and its inhabitants develop their computing power, they decide to create their own virtual universe. And the cycle continues, with each new simulation becoming capable of spawning its own virtual realities. It's like a never-ending chain of creation, where each simulated universe acts as both creator and creation. This concept is often referred to as the matryoshka doll principle, named after the traditional Russian nesting dolls, where each doll contains another within it. But why would an advanced civilization go through the trouble of running all these simulations? That's where things start to get philosophical. Some argue that these simulations could serve as experiments, allowing civilizations to test out different scenarios and study the consequences. Others suggest that these simulations could be used for entertainment, much like today's video games. Imagine being able to explore countless virtual worlds, each with its own unique challenges and adventures. But perhaps the most intriguing question of all is, who would inhabit these simulated universes? Would they be conscious beings like us, unaware they live in a simulated reality? Or would they be entirely artificial constructs programmed to behave in specific ways? These questions touch on some fundamental issues in philosophy and ethics. For example, if we were to create conscious beings within a simulation, would we have a moral obligation to treat them ethically? And if these beings were to discover that they were living in a simulation, how would it impact their perception of reality? These are just a few of the fascinating questions raised by Bostrom's ideas. They challenge us to think deeply about the nature of reality, consciousness, and the role of technology in shaping our understanding of the universe. In the end, while we may never know for sure if we're living in a simulated reality, exploring these concepts opens up a world of possibilities and invites us to ponder the mysteries of existence itself. Imagine a scenario where humanity has reached the highest point of technological advancement. Despite groundbreaking innovation and extensive exploration, Earth, our planet, is facing challenges. Its limited resources are depleting, and despite dedicated attempts, a viable alternative for colonization remains elusive. The situation is stark. Future generations are bound for a planet in decline. Is there a possibility for an alternative approach? Can we transcend the limitations of our tangible world and dive into a simulated environment? Picture the scenario where we can select a period predating our futuristic post-human era, enabling our consciousness to dwell in the comfort of the traditional 21st century, while our physical bodies progress light years ahead in time. Professor Robin Hanson, for instance. He presents a compelling viewpoint utilizing Google Ngrams, a tool that monitors the usage trends of words throughout history. By inputting a particular year, we can visualize the varying levels of interest in that year. Interestingly, the decline in interest frequently outpaces population growth, creating a noteworthy paradox to contemplate. Let's consider a different scenario. Imagine exploring a faraway, possibly livable planet instead of recreating history. Envision a vast spaceship traveling through space slowly, transporting optimistic travelers in a state of suspended animation. To combat the monotony of their extended sleep, they are engaged in a virtual reality experience. This idea originates from science fiction, a vision within a vision. Nevertheless, despite its allure, there is a caveat. Our present state of affairs is notably flawed. Shouldn't the concept of creating an artificial utopia aim to transcend the constraints of our current society? Why be content with mere replication when the potential for achieving something grander looms? This situation prompts deep inquiries regarding the essence of existence and our position within it. Are we fated to be captives of our own inventions, restricted to an artificial life that appears insignificant when contrasted with the immense expanse of the universe? Alternatively, do we have the creativity to surpass our boundaries and chart a fresh course ahead? Maybe the solution can be found at the convergence of technology and philosophy. While we are dealing with the moral consequences of constructing artificial realities, we are compelled to face our most profound concerns and aspirations. How do we define humanity in a realm where truth can be altered and limits are indistinct? The inquiries motivate us to venture into uncharted territories, to challenge the limits of what can be achieved, and to pursue significance in a constantly evolving cosmos. Whether we opt to reenact history, voyage to celestial bodies, or navigate unexplored paths, one fact remains irrefutable. The pursuit of comprehension is an endless expedition. While we navigate the intricacies of our being, we must remain cognizant of the boundless opportunities that await us. Have you ever encountered a sense of familiarity with a situation yet been unable to pinpoint its origin? Experts have posited that this experience, known as déjà vu, may stem from a temporary disruption in short-term memory processing. The brain might mistake a current event for a past memory, leading to this curious sensation. An intriguing phenomenon indeed. However, the possibility exists that memory disturbance is not the sole factor at play. What if specific experiences evoke a profound sense of recognition, as though they have occurred before? Perhaps some memories persist despite the brain's attempts to reset and erase them. It's akin to stumbling upon fragments of a former existence within your current reality. Let us delve deeper into this intriguing realm. Reflect upon the vast expanse of the world, each nation, every iconic structure, and even the ocean's mysterious depths. Are these entities truly tangible or mere constructs of our minds? Some theories suggest that our existence is part of an intricate simulated reality shaped by an imperceptible influence. It's reminiscent of living within an eternal narrative, akin to the iconic series The Simpsons, where even the most improbable predictions manifest into reality. The internet serves as a vast digital landscape where concepts originate, disseminate, and undergo scrutiny. Interestingly, some individuals subscribe to the notion that our perceived reality is a simulation, akin to living within a personal version of The Truman Show, where an unknown entity meticulously observes and analyzes our every action. The paraphrased passage upholds the initial concept of the internet serving as a platform for idea exchange and discourse. It also introduces the notion that some individuals perceive their existence as akin to a simulated reality, drawing parallels with the renowned film The Truman Show. The revised text employs elevated vocabulary and a tone tailored for an erudite audience, maintaining a formal register throughout its composition. Nevertheless, it is crucial to recognize that even highly advanced simulations are susceptible to limitations. Occasionally, unanticipated anomalies manifest on a substantial scale. Are you acquainted with the Mandela effect? This phenomenon occurs when a significant portion of individuals collectively recollect an event in a manner that deviates from its factual occurrence, akin to a glitch in the system, exposing imperfections inherent in our perceived reality. However, an intriguing facet emerges. Although the system possesses the sophistication to unveil our imperfections, it exhibits an equal aptitude for obfuscating them. Those who dare challenge the authenticity of our existence are promptly silenced, their perspectives dismissed as mere conspiracy theories. Have you ever contemplated the underlying rationale that compels specific individuals to embrace concepts such as the flat Earth hypothesis or the notion of extraterrestrial entities covertly influencing governmental affairs? These occurrences are interwoven, bound by a common thread, the conviction that our reality may not be as unambiguous as it appears. It is as though we collectively embark on a quest to unravel the verity concealed behind the facade, yearning to unmask the enigmas of our seemingly simulated existence. Déjà vu, that uncanny sensation of familiarity, can be unsettling. But remember, you are not alone in this journey of deciphering life's mysteries. We are all explorers, traversing the enigmatic landscape of existence and striving to comprehend our surroundings. Perhaps one day, through relentless inquiry and an open mind, we will unveil the secrets of the universe and the intricate puzzle of our perceived reality. Until then, embrace the unknown with curiosity. Embrace the adventure of discovery and maintain a receptive mindset. Thanks for watching, and I'll see you in the next one.